This is a 5 years old child, SOBORNO Isaac, interview with a Massachusetts Institute of Technology MIT Dr. Daniel Cabot, which took place in 2016. The child revealed having unbelievable high-level skills and knowledge in sciences like math, chemistry, and physics. Later, the White House congratulated him for his hard work, big dreams, and accomplishment. Let's follow the full interview.
Can you tell me what is your name?
My name is SOBORNO Isaac Bari.
And how old are you?
5 now.
What is your most favorite subject to study?
Math.
You like math?
Yeah.
Good for you. And what is it that you like so much about math?
Well, I want to solve a problem about it right now.
Okay. What problem would you like to solve? Can I give you a problem?
Yeah.
Okay. So I like to go on. I like to ride my bicycle. So if I ride my bicycle for 30 miles, and if I tell you where my position is as a function of time, can I give you that function? I'll write what position was as a function of time. So P of t is equal to t divided by 3 times t squared. That's my position function. And when I was riding, in the first 20 miles, I saw speed limit signs that said 25 miles an hour. And what you gotta tell me is, did I break the law? Can you use math to tell me that?
Yeah.
How do you do it?
Yeah, we don't we'll use that function later in the math.
Okay.
You draw a diagram. Remember, you need all diagrams to solve all math problems. If you had no diagram, you wouldn't be able to find out how you would solve this.
But that's right, diagrams are good.
I mean, it's at rest, then the NSO must always be 0, or TNS. So this is your bike. I don't usually know how to draw a bike right now, so I'll just draw a skateboard.
Okay, a skateboard is fine. I like to skateboard too.
So D1, there's nothing, because let's make this longer. So D1 we don't know, and T1 is equal to 1. How would that even be possible? So in D2, as you said, there was the speed limit sign, 25 mph. That stands for mile per hour, and D2 equals to 20. T2 is equal to we don't know, and at the final, let's just draw a flag. So that means that the final equals to we don't know, and T final is equal to 3 over 2, otherwise known as 1.5. Do the graph. You always need space for the points to intersect. So this time we're gonna use only 3 spaces. 1, 2, 3. This is 0.5. This is 1, 2, 3. This is 1 and 1, 2, 3. This is 1.5.
Okay.
So, and this is the origin. It's not just for the numbers. It's also for the parabola and the other stuff. So, whoops. So 1, 2, 3. This is 10. 1, 2, 3. This is 20. And 1, 2, 3. This is 30.
Uh-huh.
They'll probably intersect on the line some way. Whoops, the parabola and the line have to intersect here. So let's erase this parabola and let's try this again. No. Yep, and the line. See how they intersect at this point?
Mm-hmm.
That's we have to find the velocity of the line at that case.
Uh-huh.
So we'll do that after we find df. As we know, it's still missing. So the final, we actually use p of t equals to 3/3t². But if you already know the time, you just need to use this. 40/3t². So now we get 40/3, 3/2². So if you do the math, 3 times 3 equals 9 in the 3 multiplications table.
Uh-huh.
And 2 times 2 equals 4 in the 2 multiplications table. So let's copy those answers down. So 40/3 times 9 over 4. So 4 goes to 40 10 times. I gotta push my chair in if I want to sit. So that 10 times 3 and the result gives you 30. So this must be 30.
Very good.
Now let's erase this stuff. I'm a lot older now, because that's why I know this problem so much.
Uh-huh.
So T2, oh wait, we're doing this. So the velocity is df minus di over tf minus ti.
Very good.
So df is 30, and the initial is always 0. So 3/4 of our fraction is done. 30 minus 0 over 3/2 minus 0. That leaves us with 30 times. We flip this fraction like this. So 2 goes to the top and 3 goes to the bottom. Let's copy that down. So 2 and 3. So 3 goes to 30 10 times.
Mm-hmm.
So that gives us a result of 10 times 2 equals 20, because in the truth table, 2 times 10 equals 20.
Very good.
Anyways.
So how do you know if I broke the law or not?
Maybe could have break the law? We don't know yet. So now let's solve T2 because we know that it's still missing. This time we're doing it backwards. So T2 is T2 usually it's actually P of T equals 40 over 3t squared. I'm using P of T because we don't know the time. T2, so it equal to 1. So no. This whole thingy is replaced with 20. So 20 equals 40 over 3t squared now. Seriously? So now we add 3 over 40, the reverse of 40 over 3 to both sides. 20 goes to 42 times in the 20 table. 20 times 2 equals 40. And these guys cancel. Even though the t square is still there. So that's not included. So our answer is squared. If it was to be t squared, it will be 3 over 2 like TF is, but it's actually T2. So it's the square root of 3 over 2. Which is equal to 12.22. So
very good.
So this will be 1.22. Otherwise, consider the square root of 3 over 2. Which is the square root of TF. Or T5 I mean. So let's erase this stuff also. Again, we know the time. So we'll use only 40 over 3t squared again. So that means the time is 1. So and how could that possibly be? So 40 over 3, 1 squared would leave the same result except for the t squared, because the t is replaced by 1. So this is what you got. But if you do the other math, you got 13.33.
Very good.
So D1 you get 13.33.
Excellent.
So T1 equals 1 and D1 equals 13.33. Otherwise considered as 40 over 3. Just add t squared. That's our position function.
Very good.
Oops, forgot to write it here.
Excellent. Very nice graph, by the way.
We'll erase this stuff again. So you add this one. You see that intersecting? We'll draw a line there. And we have to find the velocity of that line again, since it also cuts on the intersect. So V equals what? So So we'll do this and then just the calculus. So
Okay.
so d2 minus d1 over t2 minus t1. Which you know d2 is 20 minus d1 is 13.33, otherwise considered as 40 over 3. But let's just write 13.33 for now. Over t2 is 1.22 as considered square root of 3 over 2, which is actually square of t final. So, let's just write 1.22 for now minus t1 equals 1. So yeah. Yeah, that gives us 6.74. I don't know the rest of that. It might sound like pi or something. And 1.22 minus 1, which is 0.22, which is equals to 31 mph.
Oh, is that right?
Yeah. But
Okay.
wait, no.
Does that sound like I'm breaking the law? I don't know. Now I'm kind of worried.
No, 31 is bigger than 25. If it would have been that mph, you would have broke the law, but it's not that mph.
So I could be in big trouble. I gotta know. Did I break the law or not?
It's a little bit close to 31 mph.
Okay.
P of t equals 40 over 3 t squared. Hey, that's our position function. So P prime of t equals to limit as delta t goes to 0. I'm thinking about eating that candy right now.
I am too. Because it looks pretty tasty.
Yeah, it's chocolate. So limit as delta t goes to 0. 40 over 3, parenthesis, t squared plus delta t whole squared minus 40 over 3 t squared. That's our position function.
Wow, okay.
Over delta t.
Uh-huh.
P prime of t equals limit as delta t goes to 0. So 40 over 3. How did this just get bigger? T squared plus 2t delta t plus delta t squared minus 40 over 3t squared.
Wow.
Wow, that's a very big one.
That's a big formula.
Over delta t. So we'll distribute this stuff.
Okay.
So if we do, that gives us p prime of t what? You'll get an even bigger formula.
Really?
Yeah. Limit as delta t goes to 0. 40 over 3t squared plus 2t plus 80 over 3t delta t plus 40 over 3 delta t squared minus 40 over 3 t squared. I meant to get this parenthesis over delta t. I couldn't have space.
Kind of running out of space.
Yeah. So that leaves us canceling out 40 over 3t squared and this one. So 5 of t equals limit as delta t goes to 0 plus 40 over delta t squared over delta t squared. Wait, this is 80 over 3t delta t plus 40 over 3 delta t squared. So
Looks good.
So p prime of t equals to limit as delta t goes to 0. Watch this. Delta t parenthesis 80 over 3t plus 40 over 3 delta t over delta t. Delta t canceled. This is kind of like y equals x squared. So p prime of t equals to 40 over 3t delta t goes to 0. So to start off, the equation kind of gives you a clue. So read what me. This is 80 over 3. This is not the actual answer because this is just a part of the other formula. Here's the real answer. So here of 1.22 equals to 80 over 3, 1.22. What gives you 32 and pH? You sure did break the law.
Really?
I told you it was close to 31.
Wow.
You really did break the law.
Am I in big trouble?
Yeah.
Uh-oh, I better watch out.
Yeah.
So besides math, what else do you like?
I like chemistry also.
Oh, okay. Anything in particular about chemistry that you like?
Maybe the periodic table.
Oh, really? Oh, that's some very important chemistry.
Yeah, I pinned that on my bedroom wall, but now I took it off.
Oh, really? Wow.
Yeah.
That's a nice thing to have on your bedroom wall. Let's see. Would you like to write the first 100 elements of the periodic table?
Yeah, but there's actually 118.
Oh, really?
Yeah.
Okay. Are you going to stop at 100 though?
Yeah, maybe.
Okay. Well, 100. All right. Go ahead and.
I need to stand up if I want to write the first 10 elements.
Okay.
Hydrogen, helium. Whoa, this is gotta be super hard. So I gotta pull this.
Let's see. Do you want me to hold it up for you like this? Is this easier?
Maybe, yeah. Lithium, beryllium, boron, argon, nitrogen, oxygen, fluoride, neon. Hey, this is almost like your board.
Uh-huh.
So, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, fluoride, argon, potassium, potassium, calcium. I'm now getting smarter and I'm doing things faster because I'm getting older.
Well, you're getting older and you know more practice. That's good.
Yeah. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Copper and zinc are the two elements you use for a lemon battery. That's why they're special.
Wow. Yeah, I remember when you made a lemon battery for me once.
Yeah, the other time I met you. I'm not gonna do it today because my dad might not have time.
Okay, maybe you can make another lemon battery for me some other time.
Yeah. So, gallium, germanium, arsenic, selenium. Oh wait, arsenic, selenium, bromine, krypton, rubidium, strontium, yttrium, and zirconium. If I make a mistake on the periodic table, that's okay because everyone does mistakes.
That's true, everyone does.
Yeah. Zirconium, niobium, molybdenum, magnesium, rubidium, rhodium. Wow, this is pretty. Your markers are pretty better than compared to mine.
Oh, really? Okay, well, yeah, if you need another marker, you can always borrow one.
Oh, I don't need it. I already have a marker. Selenium. Wait. So, rhodium, palladium, silver, cadmium, indium, tin.
Right.
Don't worry, we don't need this eraser. I could erase with my hands.
Okay, if you want.
So anyways, tin, antimony. Some people, when they announce these three elements, they say, where are you? Yeah, totally. But this time we're not going to say it.
Okay.
Antimony, beryllium, iodine, xenon, cesium, barium, lanthanum, cerium, praseodymium, neodymium, promethium, samarium, europium, gadolinium, terbium, dysprosium, helium. I'm thinking about doing the Dr. Kabat problem again.
Yeah. The one with me on my bike?
Yeah.
Well, you did a very good job with that one.
Erbium, thulium. Did you have any questions why thulium is icon as a pad in the periodic table song? Maybe because some pads are made out of thulium.
Oh, maybe so.
Yeah,
I
maybe.
never thought about that.
I have a good thought about that too. So this is thulium, ytterbium, titanium. Hey, when we were at Styrium, we were at the lanthanide. So I don't want to write that right now.
Okay, you don't need to if you don't want to.
Yeah. Titanium, hafnium, tantalum, tungsten, medium, osmium, iridium, platinum. What's after platinum? Wait, it's gold, right?
Okay.
Gold, mercury, gallium, bismuth, lead, polonium, aspartame, radon, francium. Daddy's running out of time. That's why I have to, but I still want to complicate this. That's why
Okay.
we might want to do this faster.
All right, so you're going to zip through the periodic table?
Nope, not in a rush. This looks terrible, but that's okay. Francium, radium, wait, Yeah. Radium comes after, then after actinium is thorium. Aren't we in the actinides?
I think we are.
So tritium, uranium, neptunium, plutonium, americium. That's for our country. Berkelium, California. Wait. Americium, curium, berkelium, California. That's for California. Einsteinium, fermium. Maybe next time we could stop at Einsteinium, which is the 99th element, because Einsteinium is my favorite hero.
Is that right? Wow.
Yeah.
Well, very good. Well, I have a question, which is, could you tell me about the electron configuration of oxygen?
Yeah.
Ooh.
It's very short.
Oh, okay. What is it?
Here's the nucleus.
Okay.
So 1s, 2s, there's one room also, and 2p is 3 rooms. 1, 2, 3.
Uh-huh.
Only 2 arrows could fit on each floor, room. And we have 8 arrows. 1, 2, 3, 4, 5, 6, 7, 8. So 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, and 5.
Oh,
Yeah.
what is
5s, 5p, and 5d.
Wow.
So 1s, then you go to 2s, then you go to 2p, 3s, then 3p, 4s, then 3d, 4p, 5s, then 45p, then 4s, 5d.
Wow. Very good.
So now two arrows are out of here and into 1s.
Uh-huh.
So 2 arrows are caught into the second room
Mm-hmm.
and the roofs, and the remaining 4 go into 2p, which has 4 rooms.
Uh-huh.
So 4. So we'll write the equation before we leave this problem. I told you it's so short.
It is kind of short.
Oxygen configuration, or OC, equals to 1s squared 2s times 2s squared times 2p fourth.
Very good.
Yeah. So
All right. So what else do you like?
physics.
Okay. Okay. Would you like to solve a boat problem?
Yeah.
Okay. So suppose there's a boat on a river, and suppose Isaac is pulling it using a rope.
Yeah, I'm called Isaac.
So let me give you the problem. So suppose you're pulling it using a rope, and you're applying 40 newtons at 45 degrees northeast.
So Fi equals 40 Newton and Fa equals 30 Newton. So how many components does Fi have?
Let's see.
Fix and Fiy.
Uh-huh.
1 and 2. Force Alberta also has two components, but let's talk about that later.
Okay, let's do your force first.
Yeah. Let's do my force first because I'm younger.
Makes sense.
Yep. My brother is 14.
Oh, wow.
5 plus 9 is 14.
That's true.
He's 9 years older than me each year. Yeah.
Well, someday you're going to be 14.
Yeah. So Fix equals to Fix equals to cosine 40.70, which gives us 28.3. You'll be guessing that Fiy is also 28.3.
That's right.
Actually, that's correct. I'll prove it.
Oh,
Fiy equals to sine 45 degrees. So at 40 times 0.70 again equals 28.3.
So they're the same.
Yeah.
Wow, okay. Very good.
But for us orbital, they're not the same. Here, I'll change this for you very fast. So, this is changed now.
Okay, so now you're doing your brother.
Yeah. Sine, cosine 37 degrees equals to. I'll prove you how it's different.
Okay.
So, cosine 37 degrees equals to. It's. I'm having a little distribution with this, but that's actually 30 times 0.80, so, which is equals 24 newtons.
Wow, very good.
I'll prove it that Fy is different. Unlike the other two components of so Fy equals to sine 37. Oh no. Sine 37 degrees. Watch how I do it. So sine 37 degrees equals to 30 newtons. 80. Oh no. 0.60. I meant minus 30 degrees. Now minus 30 newtons times 0.60, negative 18 newtons.
I see, okay.
Now they're different.
They're not the same anymore. All right, very good. So
So
what's the net force?
Fx and Fy, which Fx is equal Isaac x, which is xvx, and Fy is equal to Fx is equal to Fpx and plus F my brother x, Fax and Fix. So yeah. It's so
I for
cool.
Isaac.
So Fix plus Fax and Phi plus Faith.
Uh-huh.
So
If you add those, what do you get?
we get 28.3 plus 24, which is equal to 52.3.
Very good.
5 plus Faith equals to 28.3 also, as we were doing before, plus minus 18, so equals to 10.2.
Very good.
So here's a Pythagorean. Let's use the Pythagorean method.
Sounds good to me.
So, 52.3 times 52.3 whole square times that is 10.2 is how much electron volts that the electron needs to jump from R1 to R2.
I guess that's true. Right?
Yeah, that is true. I'm still thinking of the hydrogen ionization. So anyways, this squared and it's equal to 53.3 newtons.
Wow, so that's the force on the boat.
Yeah.
Very good job.
Thanks, Professor
Well,
Gabar.
thank you very much. Thank you for explaining to me about math and chemistry and physics.
Happy holidays.
Happy holidays to you.